All right, so this is the 5th lab for this course. What we're going to be doing here is proving a turbine flow meter, doing a volumetric prove on it. So this is our turbine flow meter right here, and it's connected to a totalizer up top. I've got it all turned on, and just to kind of walk you through the way that this is all plumbed in, if you see down here, the pump discharges, and the fluid, or water in this case, flows through our turbine flow meter. We've got a valve, a ball valve here on the discharge, and then it comes down and over into our tank right here. And this tank has a tape measure on it, so we can measure the height of the fluid, and if we know the diameter, inside diameter of the tank, we can figure out the volume that is flowed through the meter. And then off the bottom, we have a ball valve here as well that we have plumbed in, and it flows down to our tank at the bottom here. So we're gonna use this to prove the meter. The first thing we're gonna need to do is we wanna count every single pulse that flows through, or every single time that the turbine causes a pulse on our pickup here. And we want to pick that up. So to do that, we want to, this is a 1/2 inch meter, so it's set correctly there. We want to go to, we want to be using pulses per liter for our units. And we want our K factor, I've already done this, it needs to be a value of 1 for doing the prove. When we actually figure out our K factor, it'll get entered in here and it won't be a value of 1. But we want this to be set up for 1. What that's gonna do is every time it pulses, it's gonna count as a liter, so we can figure out the total number of pulses. I want this set up for liters per minute / liters, and we wanna display only the total. So we can change this so it displays rate and total, but we just wanna display the total. So our meter should look, our readout here, when we get back to the main screen, it should be reading in liters, and it should be set for 0. If we need to reset it, we push these 2 buttons to reset the total flow. So what we're gonna do here is I'm gonna put some water in the tank here, and we're gonna record some values. If you look over here, our lab procedure, we have this table to complete. We need to do 4 runs, record the start height, the end height, and the number of pulses that our totalizer displays there. And then we can calculate the volume and then the K factor in pulses per liter. So I've got a table drawn up here on this whiteboard so I can record all those values, the start, stop, and the pulses. So I'll go ahead and get this thing ready. I'm gonna turn on the pump. I'm gonna put a little bit of liquid in here. We want the liquid to be above our connection point here, just so we're gonna be always starting above and finishing up here, so we know the actual volume. Because if we start below here, there's gonna be some volume that gets included that's going to be missed here, right, in our calculation. Just like we had to modify this tank, we did have a pipe that was installed in the tank as well, and this takes up volume here, so that would give us an error as well. So I removed that from the tank. So what I'll do is I'll put some fluid in here up above that nozzle, up above that connection point. All right, so I have our pump turned on, and I ran some fluid in here. The first little bit, it kind of sprayed up a little bit, so that's why we've got some water there. But now that we have water sitting on top here, it shouldn't spray. But so yeah, I opened this valve for a bit, let it fill up, and then I shut it. And the bottom valve is shut as well, so we're trapping fluid. What we'll do is we'll take our first reading, our start reading. I'm just gonna lower this level a bit. I'll open this valve down here, just lower the level a little bit, down to about 70 millimeters or so. So there, we stopped. We actually stopped, it looks like right at 70 millimeters. This is 7 centimeters or 70 millimeters for our start. I just threw up 70 here on the board to show that. So now we're ready to open this valve over here. We'll see our pulses start counting and our level rise. So I'll go ahead and do that. So the pulses are increasing, and you can see down over here, our levels rising. Once it gets near the top of the vessel, I'm gonna shut the valve and record our end height and our pulses. All right, shut that quick, and there, 19,427. And our level came up to, this is 50 centimeters or 500 millimeters, so we're about 504 millimeters. So right. All right, so we've got our first run completed here. I'm gonna go ahead and complete the other 3. So before I do that, I'm just going to need to make sure that I reset this total back to 0. And then I'll drain the tank back down to a new start level and just keep doing this, leaving the pump on so the lines are all pressured up. So we have instant flow when we open that valve over here. All right, so we just finished up our last run here. You can see our last pulse count here. Final height on the tank. Pump's still running. Kept the line all pressured up. We have all of our values here on this table. So these are all the values, the start and stop values, and all the total pulse count that the totalizer had for each of the 4 runs. So you'll need that. You'll need to go on and calculate your volume based on these start and stop heights, and the K factor for each run, and take the average. So following the lab procedure, it'll guide you through all that, but you have the data that you need now. One last thing here, I believe in the lab procedure there's a P&ID with the inside diameter of this vessel, but just to prove that it's correct here, I used a vernier caliper and I've put it in here already and got this measurement. And so we'll just show you the inside diameter here for proof. So you can see 0 right here. 0, if we slid this all the way over, would line up with the 0 line right here. So we're going to the nearest millimeter, and this is all in millimeters on the bottom here. So 0, we go up to 130, and then the 0 line lines up with the 9th division there between 130 and 140. So 139 millimeters. We're going to go to the nearest millimeter. We're not going to go down to 0.2 of a millimeter. We don't need to be quite that accurate in this case because all of our height measurements were just in millimeters. So we'll just go to the nearest millimeter, and that would be 139 millimeters for doing your volume calculation. The last step of this lab, I've calculated the K factor here based on the average K factor, and I've entered it into the totalizer now. You guys are going to figure that out, so I'm not going to show you what the value is. And I'm just draining the tank down right now, but I'm going to go and open this valve. And I've got the meter now set up to display the flow rate. So you can see right now, it's now calculating the correct flow rate. And if we look close here, it's reading 16 liters per minute there. Now, so instead of a total being displayed, I've changed it so it displays a rate. And it has the correct K factor now, so it can figure out the flow rate of the liquid into the vessel right now. So I'm just going to go and shut that off, and we should see that drop off to 0 because the turbine's no longer moving there. So there, it did. All right, so that's everything for this lab. Good luck with figuring out your K factor value.